Alrighty, so we're going to do part 2 of the Unit 2B3, Rational Inequalities, just a couple of quick examples. Now this is very similar to what we just did in the first half, only now we're dealing with the rational, the P of x over Q of x type thing. So the tidbits here is you're only going to change signs at the zeros, and then it's undefined values, basically. It's vertical asymptotes. Alright, we're not going to worry about the horizontal asymptotes. And these are going to be our critical values, so we're going to do the exact same thing. Now, the vast majority of the time, we're not going to be graphing these things if I'm asking you to solve a rational inequality. I don't hardly even remember doing much of these in my college courses. I know I did. I remember doing the minus, plus, minus, and all that in analyzing these functions. This is just going to be part of some of the stuff you'll do in the future. But we can take a look at the graphs and certainly see what's going on here, so we're less than 0 or whatever. But it's just going to be much easier just to do it algebraically. So let's go ahead and take a look at this little rational right here. So the first thing you want to do is basically find your vertical asymptotes and zeros. My vertical asymptote is going to be x is equal to 7. And I have a 0 up top, and that's going to be x is equal to negative 3. So I'm going to go ahead and plot those. There's my 7 way over here, and here's my negative 3. And I'm going to go ahead and do test values. So I'm going to do a test value here, and a test value way over here. So I could toss in negative 4 or negative 5 or whatever. And when I do that, I'm going to have a negative on the top and I'm going to negative on the bottom, and that's going to create a positive. And so I'm going to have a plus sign right here. I get to use 0 again. That always makes me happy. So I have 3 over negative 7. That gives me a negative. And then I'm going to use some number over here, say 10. I got 13 minus 3, so I'm going to have a negative a positive over here. Okay, so I have a positive, negative, and a positive. All right, and so that's just pretty much my solution. I'm going to go ahead and write it. I have negative infinity to 3. We're non-inclusive because there's no equal sign here. So I'm going to have negative infinity to negative 3. I'm going to union that with wait a second, am I doing? Yeah, I'm doing positive. Ha! Always look at that, whether you're doing negative or below 0 or above 0. And I'm going to have from 7 to infinity. All right? There we go. Let's take a look at the next one. This next one can be a little deceptive, but it's still a pretty basic one. And we have a little bit of translation going on here. So what we have here is the exact same thing. We're going to find the vertical asymptote, or the zeros first. So that's going to be x is equal to negative 1. So I got my vertical asymptote right here. That's going to be one of my critical points. And my other one is not going to be 6. It's not going to be that. It's 6 minus 2, because when I put in zeros right here, I have 6 over 1, 6 minus 2. So my 0 is just 6 minus 2, which is equal to 4. So I'm going to put that right there. So you watch out for these little traps and tricks. So I got to do 3 interval tests. I got to do test here, and test here. So if I put in negative 2 right here, I'm going to get a 4 over negative 1. And you think, oh my goodness, that's going to be a negative. Well, you're correct, because I'm going to subtract 2. But if you did like 100 and you got 106 and 101, you're thinking that's a positive. And then you subtract 2 and you're thinking a really big positive minus 2. That's a trap. This is a very small fraction. Because what's really going on here, and I'll do the little sketch of the graph here. And you've seen the reciprocal function. We're playing around with the reciprocal functions, basically. I didn't do a very good job because I have a vertical asymptote of negative 1 here. So it gets very, very close. You have a horizontal asymptote of 0. It's not going to get above that line. All right, so we have a negative. So I have a negative right here. When I put in 0, well, I got 6 minus 2 is going to give me 4 or whatever. I'm going to have positives in this interval. And when I put in a big number over here, say 5 or 7 or whatever, well, I'm going to have a small fraction again. And I'm going to subtract 2. I'm going to get a negative. All right. So let's go ahead and do that. We're going to negative. Because this right here, this function, which I kind of sketched, translated down 2. All right. Okay, so let's go ahead and do our intervals. And I have negative infinity to negative 1. And then union that with 4 to positive infinity. All right. So watch out for these traps. This is a little bit of a translation. So if you had your parent function kind of graphed, you're thinking, okay, that's going to be negative over here, that's going to be over here, and you just moved it over with your vertical asymptote. Nope, we translated everything down. Okay, so watch out for these little things.